Good morning, y'all. So I hope y'all did well with your homework this week. And with all of that being said, as usual, I'll be right here showing y'all the type of problems y'all should be working with. And I'll show you kind of my way of solving it. So let's get right into it. All right. Our first question is about the conversion charts with the jacks and the jills and all that stuff that you have been provided. So the main key with that is to understand that each thing is pretty much double the size of the previous item. So for example, let's say we have one jill here. That, based on our chart, we know that a jill is equivalent to 2 jacks. And we know that a jack is equivalent to 2 of these. So 2 jacks is equivalent to 4 of this, and that all adds up to be 8 mouthfuls. And so the main thing you need to know is that each of these one of the larger objects is going to be double of the smaller object. I'll point that out to you. So a jill is going to be twice as much as a jack. So it basically adds on. Each object adds on by doubling in size. So once again, that concept will repeat with a cup. With 1 cup, that's the same as 2 jills, which is 4 jacks, on and on to the line until you get 16 mouthfuls. And then finally, we have for a pint, that's 2 cups, 4 jills, 8 jacks, and that ultimately adds up to 32 mouthfuls, as we are showing here on our diagram. Now, how much can we fit all of these into, say, a pail? Well, a pail, pretty much a gallon is half of a pail, and then the next that is a bottle, followed by a pint. And the key with that part is it highlights what we've been talking about, which is adding half of something. So if we had a half of everything that we have figured up to this point, we should be probably a mouthful short of filling up this pail since everything is, because if we getting half and halfway there, we should be about 1 mouthful away from filling up this pail completely. Now, next question. So, let's say we have a triangle here with sides of 48 meters, 69 meters, and 82.3 meters, and a height of 41 meters. So, let's start off by finding the perimeter, and that is simply just the addition of all the sides that you see here. So, where can these be found? Well, right here, 48, 69, and 82.3, so right on the outsides of the triangle. So we add them up together to get a final perimeter of 199.3 meters. We're also going to be looking for the area, which is the room inside of our figure. And that is half of the base times the height. Our base is 82.3 and our height is 41. The multiplication ends up coming out to 1,687.15 meters squared. Let's do it again with another triangle. This one has side lengths of 88.8 inches, 37 inches, and 96.2 inches. And of course our right angle. Once again, perimeter is just adding the sides, so 96.2 plus 88.8 plus 37 is all going to add up to 222 inches. And that should have 88.8 in your PowerPoint slides if you are taking notes. Now, area, once again, half of the base times the height. Our base here is 88.8, and that's always going to be this side here that's the longest and straight. And our height is the one that goes up and down vertically. So that is 37 inches, and that all adds up to that all comes out to be 1,642.8 inches squared. Let's try it again to see. We have our triangle here
with sides of 8.5 centimeters, 6.2 centimeters, and 3.1 centimeters. Oh, we have a height here of 2.6 centimeters as well with a right angle. So once again, perimeter, just add up the sides. 8.5 plus 6.2 plus 3.1 equals 17.8 centimeters. The room inside the figure, half the base times the height. Base is 6.2, height is 2.6. Your final math comes out to 8.06 centimeters squared. All right, moving on to question number 3. We have our circle. We have a large circle where a square and a small circle are inscribed inside of that. And this has a height of 10 and a radius of 5. And we can actually create a triangle here with the hypotenuse being r to help us find the area of the circle. So area is pi radius squared. So radius is 5. Square that, you get 25 pi units squared for your area. Now, to find the length of this, of r, we need to work on the Pythagorean theorem. So that formula is a squared plus b squared equals c squared. We know 5 squared, and we know this is 5. So 5 squared twice is 5 squared is 25. 25 plus 25 is 50. 50 is equivalent to r squared. So we need to subtract the large area of the circle from the small area to find what we are looking for. So 50 pi minus 25 pi is 25 pi, and therefore the areas are the same. Now for question 4, we have our cylinder here, and a circle and a triangle that are inscribed within our cylinder. The base is r, and our height is 2r. Now with these conditions in mind, how would you find the volume of all 3 figures that are represented? Well, let's look at what we know. For the cone, we know that we have the volumes of actually all 3 figures listed right here. So let's put them to good use. Now, the height is 2r compared to our base, which is just simply length r. With this in mind, we can apply these to our new formulas right over here by doubling their length. 1/3 becomes 2/3, 2/3 becomes 4/3, and pi becomes 2 pi. So with this in mind, our ratio turns out to be 1 to 3, no matter how the multiplication comes out. And that's the concept being applied for question 4. Now, for question 5, let's say we have this figure here. One of its lengths is with lengths of 26 centimeters, 12 centimeters, 12 centimeters, 4 centimeters, 17 centimeters, and 15 centimeters. So we know that this is a right trapezoidal prism, and if we want to find the perimeter, we just add up its outer lengths. 26 plus 17 plus 15 plus 12. We don't count the 4 because it's referring to our angle right over here, but you add up all the sides to get a perimeter of 70 centimeters. And once again, our area is half of a plus b times our height. And to apply it, we add up 26 and 17 for a and b, and multiply that by our height here, which is 12. That comes out to 258 centimeters squared. And then our surface area, we use this information to calculate our surface area by creating this formula, which equals out to 796 centimeters squared. And basically the goal here is to identify the shape that you're working with. And once you identify that, you work by finding the perimeter and the area of the figure to get the numbers that you need to apply to your surface area formula. Once you have the numbers, you just plug in the formula of the surface area of the figure to come up with your final answer. But that's the key. And we'll demonstrate that again here with a different figure. This figure consists of a triangle on the top and a rectangle on the bottom, all of them with right angles, and lengths of 15 meters, 7 meters, 8 meters, and 17 meters. Once again, we need to find the surface area. We need to start off by finding the perimeter of the triangle. So we add up the sides. 15 meters plus 7 meters plus 80 meters. 8 meters, 17 plus 15 is 32, plus 8 is 40. the area, half of the base times the height. Our base here is 8, and our height is 15 meters. Multiplication adds up to 60 meters squared. So we can apply this to, once again, we have the information needed to fill in the surface area formula, which is 2b plus ph. So that is 2 times 60 plus 40 times 7, and we have our answer right down here. Finally, for the last question, you have this little figure right over here with lengths of 21 feet and 8 feet. And first, we want to start off by actually finding the surface area here. So, once again, we combine the figures, the area of both figures, to get our ultimate formula, which is 2 pi radius times the height plus 4 pi radius squared. Now, the radius is going to be half. So for this figure, we know that if its diameter is 8 feet, its radius has to be 4 feet, since the radius is half the diameter. And then the length of the height of this figure in the middle is 21, as that is given to us. So applying that to our formula gives us a surface area of 729 feet squared. That is rounded to the nearest integer. Now we want to find the volume of the figure. We know that it consists of 3 figures, 2 spheres and a cylinder. So therefore, since we have 2 spheres, the sphere volume is double, and we combine that with the volume of the cylinder to get our final formula. So that final formula is 4/3 pi radius cubed plus pi radius squared height, and it gives us 1,324 feet cubed for the volume. Now, let's try it with this figure here, with a triangle and another cylinder. This with lengths of 10 meters, 2 meters, and a height of 6 meters. Let's start by looking for the surface area again. Surface area for this figure is pi radius squared plus 2 pi radius height. And then we're going to combine this with the surface area of our cone to get the final formula. So our final formula is listed here, and then once you get this formula, that's the key. You want to add up the formulas of find the volumes of each figure and add them together. That formula is listed here, and then you just plug in your numbers to get your final answer, which is 56 pi, or 176 meters squared when you round to the nearest integer. So let's try and find the volume now. Well, the volume here, our volume for the formula here is listed here, pi radius squared times our h1, which is this height right here, plus 1/3 of the pi times b, which is our area of the cone base, and that's what 2 is referring to, and then the second height. We know that h1 is 10. We have all this right here, but we don't know what h2 is. Well, we can find that by using the Pythagorean theorem to try to find the missing side. So we start off with, 6, we have our formula here, 6 squared for one side, 2 squared for another side, and we do the Pythagorean theorem, and our missing side comes out to be 5.66 meters when rounded to the nearest hundredth. We now apply that to our formula to get our final answer, which is 149 meters cubed. So that's the thing with this problem. You want to add up the 2 formulas together, so that way you get an ultimate formula, and then you just search for the numbers and apply the formula to get the final answer. Thank y'all so much. I'm sorry, but thank y'all so much for listening today, and I'll be back next week to help clarify some of any questions you might have. Thank you so much, y'all. Have a good week.